Hello, grade 10 students. This time we will be talking about geometric series. Specifically, I will teach you on how to determine the sum of the terms of a finite geometric sequence. Okay, so we have here finite geometric series. A sequence is finite if its domain is the set of integers which has a last term n. Meaning to say, we are certain on how many terms we are going to add. So we are certain on the number of terms we are dealing in that particular sequence. When it is so, then we are dealing with a finite geometric sequence. Okay. Without having to add all the indicated terms of a finite geometric sequence, the partial sum of the first n terms can be determined. How? Without actually adding all the terms. We are going to use a certain formula. So, what is this? Okay, the partial sum of the first n terms is given by this formula. We have S sub n is equal to first term times the common ratio raised to the power of n minus 1, okay, divided by r minus 1. And this is only for any r or common ratio which is not equal to 1. It should not be equal to 1 since if this will be equal to 1, our r, so this will be 1 minus 1, that will become 0. So this particular formula can be applied for any r which is not equal to 1. Okay, so we have here S sub n. This is the sum of n terms. Okay, and the number of terms is represented by n. And the first term is represented by a sub 1. And the common ratio is represented by r. Okay. Okay, we also have other formulas to bear in mind. We have S sub n is equal to n times the first term. We also have S sub n is equal to 0. And partial sum is equal to the first term. Okay, when shall we apply these formulas? Okay, here. This one, S sub n is equal to number of terms times first term is applicable if our r is equal to 1. Previously, the previous formula I showed you that was applicable only if our r is not equal to 1. But if it is equal to 1, we will simply multiply first term to the number of terms. That is how to determine the partial sum. Now for this part, S sub n is equal to 0. This is only for any r is equal to negative 1 and n is even. Okay, take note. Our partial sum will automatically equal to 0 if our common ratio is negative 1 and the number of terms is even. Now, our partial sum will be equal to the first term if our common ratio is equal to negative 1 and our n is an odd number. So, our partial sum will be automatically equal to the first term if our common ratio is negative 1 and the number of terms to be added is an odd number. Okay. Examples. What is the sum of the first 8 terms of the sequence? 4, 12, 36, 108. So applying the formula, first is we are going to determine this data. Informations, we have n here is 8. Since we are going to add 8 terms, so our number of terms is 8. Our first term is 4. And our common ratio is 3. How did we get 3 again? That is 12 divided by 4. It's 3. 36 divided by 12, that's also 3. So our common ratio is 3. Now, applying the formula here. Since our r is not equal to 1, so we can have this formula. Okay, partial sum is equal to the first term times quantity r raised to the power of n minus 1 divided by r minus 1. Okay, our n here is 8. So sum of 8 terms is equal to, our first term is 4. Our common ratio is 3, this one. Our n again is 8, so this one, minus 1 divided by r is 3. Okay, minus 1. Simplifying, we can have this part here. This one, 3 exponent 8, meaning you will multiply 3 8 times by itself. So it's 3 times 3 times 3 and so on. We come up with 6,561. So we have here minus 1, we have here 4, and then we have our denominator 3 minus 1, this part here. Okay, next is we will simplify this expression here. 6,561 minus 1, so it's 6,560, times 4, and that is 26,240, divided by 3 minus 1, and that is 2. So we can have sum of 8 terms is equal to, divide this 26,240 by 2, so we have 13,120. Therefore, if we are going to add 8 terms of this geometric sequence, we can have 13,120. So this is the partial sum of the 8 terms of our geometric sequence. Another example. Okay. What is the sum of the first 11 terms of this sequence here? 3, negative 6, 12, negative 24, and so on. So take note, our n here is 11. Since we are going to get the sum of the first 11 terms, therefore our n is 11. Our first term here is 3, this one. Okay, and our common ratio is negative 2. Since negative 6 divided by 3, that's negative 2. Or 12 divided by negative 6, that's also negative 2. Okay, so our common ratio is negative 2. Now, applying the formula, you can have our n here is this one, it's 11. Our first term, this one here, it's 3. Our common ratio is negative 2, this one. N here is 11 minus 1 divided by our r here is negative 2 minus 1. Okay, simplifying this part, this one, negative 2 to the power of 11, or negative 2 exponent 11. So multiplying negative 2 11 times by itself. So it's negative 2 times negative 2 times negative 2 up to the 11 times. So we can have negative 2048 minus 1. Okay, copy this 3 here and this part. Okay, next is, you can have negative 2048 minus 1, it's negative 2049 times 3, and that is negative 6,147 divided by negative 3 minus 1, and that's negative 3. Okay, simplifying this part, you can have sum of the 11 terms is equal to positive 2,049. So this is the partial sum of our geometric sequence having these 11 terms, 2049. Okay, how about number 3? What is the sum of the first 30 terms of this sequence? 30 terms. Okay, you have negative 5, 5, negative 5, 5, then negative 5. What do you think is the sum? Okay, take note. What is our common ratio here? That is negative 1. Okay, you can have here. Our common ratio is negative 1. Our first term is negative 5. And we are going to add 30 terms. Okay. So take note, our r is equal to negative 5. And we have even numbers of terms to be added. So if you still remember, our sum here is equal to 0. Why is it so? So previously, I showed you that if our r is equal to negative 1 and our n is even, we will simply use this one. Sum of n terms is equal to 0. So you don't need to solve, you don't need to add up to the 30 terms, but simply you can have 0 as our sum since our r is negative 1 and we have even number of terms. Okay, so as easy as that. Okay, how about, okay, take note of this one. If our r is negative 1 and our n is even, then automatically the sum or the partial sum is equal to 0. Let's have number 4. What is the sum of the first 107 terms of this sequence? Negative 4, 4, negative 4, 4, negative 4. Okay, take note. Our first term is negative 4. And our r is negative 1. Here, negative 4, 4, positive 4 divided by negative 4, it's negative 1. And our n is 107. Take note, our r is negative 1. And our n is an odd number. So, our sum or the partial sum or the sum of the 107 terms of this geometric sequence is equal to negative 4. Why is it so? Take note. For any r is equal to negative 1 and n is odd, so we will simply apply this. Partial sum is equal to the first term. Since for this problem here, our r is negative 1 and our n is 107, which is an odd number, so automatically the partial sum is equal to the first term. What is the first term? It's negative 4. So you don't need to solve, you will only look for the first term. So automatically our sum, our partial sum for this 107 terms is equal to negative 4. Okay, take note of this one. How about number 5? What is the sum of the first 50 terms of the sequence 8, 8, 8, 8, and so on? Okay, so our first term is 8. Our r is 1 since 8 divided by 8, it's 1. And so on. So it's 1. Our n is 50. So we are going to add 50 terms. So our n here is 50. So our sum is equal to sum of n terms. Our n is 50 is equal to our n here is 50 and then first term is 8. So the sum of the 50 terms is equal to 400. Why is it that we are using this formula? Okay, if you still remember, for any r is which is equal to 1, okay, the sum or the partial sum is equal to the number of terms times the first term. Okay, since our r here is 1, we will simply multiply or we will simply multiply our first term to the number of terms to be added. So that is why we have 50 times 8. Our n here is 50. Our first term is 8. So multiply, we come up with 400. So therefore, our sum of the 450 terms of this geometric sequence is equal to 400. Okay, so take note of this line here. Okay, thank you for watching. I hope you learned something from this. Please don't forget to subscribe on our channel. Thank you, and this is Teacher Con. Ay, bugal-bugal te.